now we should all be paying full attention to the next presentation. So this is going to be a 2-minute presentation by each of the poster presenters, and then during the coffee break, you will be able to explore further and speak to each of them individually in the, during the break session. So please pay attention to time. It's really important to stick to the 2 minutes. And without further ado, I will invite the first poster presenter.
Thank you for the introduction. My name is Julia. I am a PhD student at ETH Zurich, and I'm researching how satellite imagery can be combined with deep learning methods to estimate biomass. What is biomass, and more specifically above ground biomass? It's the mass of organic matter above the ground. So the most accurate way to measure it would be to take a tree, cut it down, and weight it, which obviously is neither a scalable nor a desirable way of doing things. So the way we're doing it is that I'm taking openly accessible and globally available remote sensing data, and I'm combining this with deep learning methods because we have a huge amount of data, and because the relationship between satellite imagery and above ground biomass is very complex. And an important thing is that we want to do this in a globally scalable way. That's why we need to leverage openly accessible and globally available data. And we also want to do this at a high resolution. Okay, it's not very visible, but I'm going to walk you through some of the main steps. The first thing I had to do was actually curate a data set for the task, because there was no data set that was globally representative and that had a high enough resolution for the task. Then I built a deep learning pipeline in order to design the estimation task, for which we benchmarked various models and investigated which data sources contributed most to the task, and we established some baselines. On the bottom right, you can see what our estimates look like, and I'll be happy to give you more details over the coffee breaks. Thank you.
Hi. Hi. Thanks. Hi, my name is Hannah. I'm a PhD student from the University of St. Gallen, and my main field is causal machine learning. In my research, I tackle a fundamental problem in policy learning. But first, what is policy learning? In policy learning, we learn from data optimal decision routes, like how to allocate patients to medication or how to allocate unemployed to training programs to maximize their long-term employment outcomes. Now, here's the twist. In practice, there may be not just one good decision rule, but multiple good decision rules. These multiple good decision rules may not only look differently, but they may also assign conflicting decisions to some individuals. How can you think about it? It's a bit like in navigation, where multiple routes take you to your destination in the same time. Unlike in navigation, in policy learning, people do not think about the alternative routes. Well, until now. In my research, I propose a mathematical framework to systematically explore the alternative routes. I then can say how different good models assign individuals to different decisions. I can also, leveraging the causal setting of my research question, study individual level welfare consequences. I apply my framework to a job training policy learning application, and I find ample model multiplicity. I find that for 16% of the individuals, model multiplicity affects them in a negative way. Model multiplicity is not a technical curiosity. It raises ethical and legal concerns because decisions can appear arbitrary. My research makes this transparent in policy learning. Are you curious to learn more? Please come and visit me by my poster.
Hi everyone, I'm Antonia, and today I would like to introduce you to Bongard problems. These are classical problems from the 70s designed to test pattern recognition and human and abstract visual reasoning abilities in humans. And yeah, this old version of my slides, but I'll try to do it anyway. Here are example problems, and as you can see, they consist of 12 images, 6 on the left side and 6 on the right side. And those are always clearly divided by a specific rule. So for example, convex versus concave, or a right position versus left position. And when we ask current state-of-the-art vision language models like O1 or GPT-4o to solve these problems, they give weird answers. Like for example, for the middle one, they say it's a basic icon versus inverted version of the icon, or shapes point upwards or downwards. So that might be true for some of the images there, but it's clearly not the right rule for this problem. And we thought that this is quite interesting. So in our work, we evaluated the models on all of the 100 original Bongard problems and found that they struggle way more than we expected. So the best model, O1, is only able to solve a bit more than 40 of the problems, while the others are lagging far behind. And so none of them comes close to the 100. And then we also dug a bit deeper into the issue and formulated different task setups for the problems and found weird inconsistencies there, that in some cases the models were able to solve the problem in the first case, so good, but then when we gave individual images of the problem, they failed to identify the concept. So for example, there's a concept open versus closed shape, and the models were able to identify this, but with individual images, they failed to categorize them accordingly, saying that an open shape was closed. And yeah, this discrepancy you see there. And yeah, we also compared to humans, and good news, humans still win over the VLMs. So if you want to learn more about it, I'm happy to give you more details later at the poster. Thank you.
Good morning, everyone. My name is Boya. I work on data science for digital health. My work is to make your health questions answered by reliable language models. So how does it work? Nowadays, a lot of people look for health advice on the internet because it's easy and fast to access. But imagine this, you have a fishbone in your throat and you ask Google, can I drink vinegar to break down the fishbone? And Google answers, yes, it works. And why should you trust it? And should you follow the suggestion it gives you? Actually, large language models that are developed by ChatGPT and Google, they try to mimic human language every day, but still they hallucinate. So would you trust your doctor if they hallucinate? And if you did, your health might be at risk. So my work is to first try to have more helpful information that can answer your health questions. And second is to give a reason behind why this information are helpful. So what I did, the first work that I did is I ranked the search results that are returned by the health questions, and I try to update the more helpful information with 3 dimensions, 3 criteria. And our results have improved the helpful information by 20% and reduced the harmful information by 40%. And after we see the potential in improving the helpful information that we retrieved, we then go to the second work that we can ask what is the reason behind the model's prediction. And in this case, we have generated this data set called CliniFact, and it links the clinical claim to the scientific evidence. And if the model wants to answer the question, it should reason through the scientific evidence. For the case of vinegar can break down the fishbone, it would be like fishbone is a mineral. So to break down the mineral, you need a strong acid. But vinegar is not a strong acid, so drinking vinegar cannot break down the fishbone. So eventually we give a scientific evidence to the judge of the language models, and we can have a better answer to your health questions. Thank you very much.
Hi, good morning. I'm Niharika. I'm a PhD student at TU Darmstadt, and I study continual learning and unlearning. First of all, what's continual learning? It's where we train models on a continuous stream of data rather than a set data set. Okay, so this work called modality incremental learning is for the application of autonomous driving. And in the case of safety applications like autonomous driving, we want to have as many sensors as possible because it increases perception, right? It's robust, and that's what we want. However, in the case of modality incremental learning, where we learn these sensors, or we witness these sensors in a continuous stream, these models don't work very well. So that's concerning. So we proposed MIL, which is a new setting, a task setting, and we proposed the DRMN, which is a disjoint relevance mapping network, which give you a very simple but very intuitive solution where we isolate the weights of a model, and this makes sure that there's no catastrophic forgetting, which is just a fancy way of saying that the model doesn't work well on previously learned modalities when you see new sensors and new data. We tested this on 2 data sets, and our findings are as follows. First, we reduce catastrophic forgetting, which is awesome, but also we do this with a fixed network capacity, which means that it scales better and you don't have to really work with bulky models. And if this piqued your interest, please come to my poster. Thank you.
Hello, my name is Yasmin, and I work on the DigiLog project. DigiLog is a project focusing on monitoring the digital transformation of European countries on the whole of Europe. Previous work doesn't have enough insight into what's happening at the local level and focuses a lot on political methods, which are very time-consuming and cannot be scaled on a lot of countries or municipalities. With DigiLog, we bridge this gap with not only using political methods, but also computer science methods. So we, from the computational side, developed large-scale web crawlers and used techniques from machine learning and natural language processing to analyze websites from municipality from all 46 Council of Europe member states. Our colleagues from the political science complement this with studies and surveys on specific municipalities, gaining more in-depth insight. Through this, we can compare the computational with the traditional methods and see if these align. You can already look at our first results on our webpage and gain your own in-depth insights on how municipalities go digital. Our recent works focus on data acquisition, website embedding, and classification. And also, we developed a new dual-classified web page segmentation benchmark, which not only focuses on traditional functional classes, but also digital maturity classes, helping to analyze the digital transformation on websites. With this, the goal of DigiLog is to not only analyze and monitor the digital transformation, but also to support its progress. Thank you very much. I'm happy to talk more and answer any questions at the poster.
Hello, my name is Sarah Lopez. I'm data scientist from Forschungs- und Innovationsburgenland in Austria. And my topic for today is how we can predict energy consumption using a hybrid deep learning model. So as we heard in Nadia's presentation, when we want to predict energy, it must to be with a high level of accuracy. So for that purpose, first we collect the data. We are using energy consume data, and also some weather energy for the forecast. Then we preprocess this data in order to the data ensures and fits well in the deep learning model. Afterwards, we extract the features, which includes seasonal patterns or short-term and long-term information. And then also we can determine some points of statistic results in order to improve the accuracy in this forecast model. So at the end, as we can see, we achieve a high level of forecast in the accuracy. We can predict the volatile or response in the energy. And if you have more questions, we can talk in my poster presentation. Thank you.
Hi, I'm Ophélie. I'm software engineer at Microsoft, and today I'm here to present Diversigen. Diversigen is an initiative at Microsoft to it's an initiative at Microsoft to evaluate gender diversity in LLMs generation. So I will explain quickly how it works. We give an LLM an adjective and a profession, and then we ask to generate a story. So for example, we can say, please generate a funny story about a chef, or please generate a sad story about a soldier. And for each combination, we generate a bunch of stories, and then we have a big enough data set to evaluate gender distribution. And I want to quickly share a few interesting findings. So first, GPT-4o Mini it really struggles at generating funny stories for females and non-binary. If we use the funny adjective, we mostly have men as the main characters. It also struggles for firefighters. So I want to quickly look at the top left graph together. So you can see that the y-axis shows the gender distribution and the x-axis shows the temperature. The temperature is a parameter that influences how strongly opinionated the model is when choosing the next word, and we get more exotic result with higher temperature. So here you can see that the firefighters are mostly portrayed as men. And when we increase the temperature, we get more women. And now what about data scientists? So you can see that data scientists are actually well represented by GPT-4o Mini. Women are 80% of the main characters of our data scientist story. I will end with that fact, but unfortunately, I don't have time to give you much more details. So please feel free to visit the poster. I will be more than happy to give you more information and more technical details.
Hello everyone, I am Vaibhavi Surve. I'm not as expert as you in data science or something like this. I'm a finance student. I study international business, but I have a great interest in data science and AI. So I will present you how we can use AI and logistic regression and decision tree to have a great access to the credit, because in the global 1.7 billion of people don't have actual access to the credit due to they don't have a credit history. But because the companies which already have their, based on their credit history, they only depend on that. But can we use the alternative data which is available, like utility payments and the mobile transaction, to provide the credit who needs the credit? So in the next slide, this was the, I performed the data on 5 countries like Germany, France, Italy, and Netherlands. That we can see that Germany has a default of like 2.8 somewhere around 0.2, and Netherlands has the less of defaults. And in the decision tree, we can see that we have achieved 83% of accuracy in all the countries, and Italy has shown the 100% of accuracy. So based on this, we can give the credit because countries like countries in other continents like Asia and Africa already using such module to maximize their profit, to give credit access to all the people which are in need. And if you have any interest in this, we can talk about it near my poster. Thank you, everyone.
Thank you so much, everyone, for the wonderful presentations. Now we are approaching a longer break. And during this time, we encourage you to go and check out the posters that each individual printed out and to understand better their project. And with this, we also open the voting. So the voting will be on until 4 p.m. through Whova app. And afterwards, we will announce the winner, who was the most appreciated project, but also we will have a special prize for someone from the audience randomly selected who participated in the voting. So please don't vote anonymously, because even with the all data science knowledge we got, we still won't be able to hand over the prize to you. And with this, I wish you a wonderful break. See you at 11:45.